given that stress max, okay, is equal to 73 megapascal. Okay, so this is the condition that we have to meet, or that must be met. If we don't have this this value, we're gonna be in trouble. Okay, means the solution is not true. Okay, so these are the data that we have. Okay, so the next thing we do, we are going to draw a 3D Mohr circle now. Okay, we're going to draw 3D Mohr circle. So we're going to have we're going to draw sketch 3D Mohr circle from here. Okay, so I'm going to have my okay. So this is our X. So we're going to start from minus 180. No, this what we are teaching here, Omar, it will not be in the term test. Week 5. Week 5. Yeah, no, today's week 5. Okay, it's not fair. What I teach you now, tomorrow I test you is ridiculous, right? So we will have minus 180. Minus 100, 80, 60, 40, 20, 0. Then we have 20, 40, 60, 80, 100, 120, 140. I need more. 160 and 180. So normal stress. So from here, I'll draw a new one. And then we're going to sketch our shear. So the shear, we know we don't need to go more than 73. Okay, we are given that 73 is maximum. So 20, 40, 60, 80. So this is rotate clockwise. Minus 20, minus 40, minus 60, minus 80. Anti-clockwise. So one thing is for sure, right? We know that point Z, everything is equal to 0. Okay, we are very sure about point Z will be equal to 0. So from here over here at this point, this is our point Z. Okay, and then the next thing that we are going to be very sure is that the maximum shear is 73. So you can draw 73. Okay, you can sketch 73 from here. Okay, so this is the 73 line. So 73 is around here. And over here, this is our 73 line. Okay. Now, knowing that, okay, knowing that point Z is equal to 0, right? And the maximum radius is 73. We are also aware, right, that the stress max and mean will also be equal to twice times 70 or plus minus twice times by 73. So this will be equal to 146 megapascal. Okay. This is because stress Z is equal to what? 0. So stress Z is equal to 0 is like our what? Our anchor. Okay. So now I'm going to sketch in 146. Okay, I'm going to sketch in 146. So I'm eyeballing this 146. And then the next one, so the next one, this is our 146. Okay. Right. So I'm going to take this and I'm going to copy and I'm going to paste a few more times because I need this diagram later on. So I won't waste your time drawing it. Okay. Right. So over here, this is our operating boundary. Okay, this is our operating boundary. What do I mean by that? The Mohr circle cannot touch anywhere that I'm shading now. The 3D Mohr circle cannot touch anywhere that I'm shading now, outside the red box. Okay. So I'll draw a thick red box for you. Okay, this red box. Maybe I draw thicker. I'm going to draw a thicker line. It cannot touch this red box. If it touch or go beyond the red box, right, the material will fail. Okay. So let me elaborate. Okay. When you draw 3D Mohr circle, the bigger circle, okay, we're talking about the bigger circle. If our bigger circle is like this, right? It did not go out. Okay. This is okay. Okay, or structure is safe. 3D, yeah, 3D Mohr circle. And if you have a circle, okay, happen to be like this. Okay. So when we draw a circle, you happen to have one of the circle looking like, for example, okay, one circle looking like this. The fact that the circle is outside the red box, okay, structure is unsafe. Okay, just part of the circle that goes outside. So I'll draw another one. I'll sketch another one. So another circle that we're going to draw is like this. Right? So when you see this, again, over here, structure is unsafe. Okay? So it cannot go outside this red box. Once it go outside the red box, the structure will what? Will yield. Okay? So you can see I'll give you two cases where you will yield. One case where everything we are good, okay, i.e. the structure is safe. Okay, so from here we are going to draw our first situation. So now you understand the red box, okay, and then when the circle is bigger or goes outside the red box, the structure is deemed unsafe. Okay, so now let's try putting Mohr circle, okay, into one of the situation. Okay. Before we put into the situation, okay, we know that we have a load at -50 and the shear is at 48. So we're going to draw a green line, or not green line. So we have -50, right? So this is our stress X line. And then the shear is at 48. Okay, so we're going to put in our shear at 48. So this is approximately 48. And I'll go approximately 48. Okay. So by looking at the 3D the element will rotate in an anti-clockwise. Okay, so this is our point X. Point X. Okay. So now we are going to have our first condition. So while looking over here, right, we know that our XY plane is our in plane. And we know our YZ plane and our XZ plane is out of plane. Okay. So for this case, okay, we are going to have the condition that the shear XY max, okay, which is our in plane, is equal to 43. Is it 43? No, it's equal to our 73 megapascal. Okay, which is equal to 73 megapascal. Okay. So what does this mean? Okay, what does this mean? Okay, so we know this is point X, right? And we are going to find point Y, right? So the line touching point X and Y will have the maximum shear stress of 73 megapascal. Okay, of 73 megapascal. Okay, so I'm going to now sketch. Okay, now sketch a circle that touches the boundary. Okay, okay, that circle. I'm going to now sketch a circle that touches the boundary. It's not perfect because I did not. Okay, so let's say this circle touches the boundary. Okay, so I'm going to now move the circle. So this circle has a maximum shear of 73 megapascal. So now the circle can be over here. So it touches point X, as you can see. Okay, so this is one of the circle, right? Or, right, the circle also can touch on the other side. There's two possibility. Okay, there's two possibility. Okay, it can be the one on the left hand side, the circle, the one on the right hand side. Okay, so I'm going to show you the one that is going to be wrong, and I will tell you why this is wrong. Okay, so the condition that we are focusing on is where the maximum shear is 73. So this circle that I've drawn